Hello and welcome to our HopsWorks webinar on anti-fraud using Neo4j features. I'm Nathan Greenhut. I'm your host today. I'm the head of accounts here at HopsWorks, and we have Yogesh as well, who is our head of solutions here at HopsWorks and is going to show you how to scale your AI investments. Yogesh?
Hey, Nate, thank you. Hi, this is Yogesh. I'm the head of solutions at HopsWorks. Today, we are going to talk about the anti-fraud solution using Neo4j and HopsWorks, and using a accelerator, which is a low-code solution. So, the agenda for today is going to be first we'll go over what this solution is all about. We'll talk about the business problem. What is an anti-fraud problem? We'll also talk about how HopsWorks can really help you to build the solution using two different approaches. What are the pros and cons of using machine learning for building? And then at the end we can take. So HopsWorks is basically a machine learning platform. It allows you to build your model, train your model and do the inferences right on one single platform. So as compared to the traditional methods, which normally takes a lot of coding, and you have to stitch in like multiple components to build an ML solution. HopsWorks is going to be a one single platform which allows you to do better prediction, increase your team productivity, and also take your model all the way from development to production. So we'll show you how exactly the platform is architected and how it's going to allow you to build your applications on using a single platform. So, so the reason why we use HopsWorks, right? Let's understand. I mean, it's as I mentioned, it's a single platform which allows you to build your applications, right? You can build all your applications on a single platform, which means you can ingest your data and then build your features. So feature engineering can be done. Once your features are built, you can do time travel. There are multiple options what you can do with the features. You can consume these features through a Python API and then build your machine learning models. So you can do this both in online and batch mode. Typical systems are not really in online mode. So here, if you have a use case where you have to do like some kind of prediction in real time, you can consume this feature in real time, and then which will be in milliseconds. And if you have a use case where you have to consume do a lot of predictions as a batch, you can do that as well. So we have both online and batch. It is enterprise ready platform which allows you to do single sign on. So you can basically integrate to your Active Directory or maybe a single sign on library. Okay. So it's all about building, better AI, faster AI, and how can we accelerate the process, right? That's the whole reason to use the HopsWorks. So as you see in the architecture diagram here, on the left-hand side, there are different data sources in your enterprise. You can pull data from your source system, which are operation system. You can also pull in the form of a batch, which could be sending over the files and ingesting the data into HopsWorks. And then if you have other databases like, a vector store or a graph database, they can be used as well. If you have any external APIs, where you need to bring the data in real time or through a messaging queue like Kafka, that is also possible. So once you ingest your data into the HopsWorks platform, basically you start doing the feature engineering. And once the feature engineering is done, then you can start building your models, train the models, and tune the models. So there are three different steps involved here. One is feature pipeline, another is a training pipeline, and third is an inference pipeline. So using these three simple steps, you are able to build any application on HopsWorks, and you can run multiple applications on the same platform. So let's understand what is really the difference between doing with HopsWorks versus not doing. So today you may not be, let's say you're not using HopsWorks. So the traditional method of building application is, in the absence of HopsWorks, would be the data scientists are working in silos. They receive some raw data. They all do their feature engineering in their own sandbox, and these could be different departments or different application teams. And then finally, once the features are built, they build the model using some kind of desktop tool, like let's say there are multiple tools available. And then once the model is created, then these models are handed over to the IT team, which can then take it to the production. So the disadvantage of this approach is, first of all, you are cloning the same data in multiple places for different applications, but it's the same data. So there is a lot of inconsistency and duplication of data that takes place. There is a high possibility that one team may be deriving the same feature and another team may be deriving the similar feature in a different logic. So there could be different results resulting out of the same feature. And also there is an inefficiency because now you are kind of computing the same feature in multiple places. So all of this could be avoided. You can stop, like building these apps or machine learning models in silos by using a platform which is HopsWorks, which allows you to bring all the raw data, both batch and real time, and then combine them together, build your features. And once the features are done, then you can publish to various teams. Now these data science teams, now they can consume these features in a very consistent manner, also do both online and batch, and build their machine learning models. So this is all about improving the productivity of the data scientist as well as the efficiency of the overall process, all the way from building the features to consuming the features and maintaining those features and including the machine learning models, etc. Uh, so, you can build your models better, faster, cheaper. That is the goal, right? I mean, even before the machine learning consumption came into play, people used to use the big data systems where the goal is to make it better, faster, cheaper. Now you have all that data in a centralized repository, maybe into Hadoop or maybe into a cloud data warehouse like Snowflake. And you may want to consume that data and have a similar mechanism working for your machine learning models, right? So you can use HopSource for the same purpose to do your feature engineering, train your models, and deploy. So from start to finish, it's going to be one platform, which will allow you to build your models. This is another high-level overview, which shows you basically at the bottom of the HopsWorks, we are kind of combining the feature store, the OpenSearch vector DB, the model registry, and the K-serve. So these are the various components that are required to build an ML platform. It starts all the way from building the feature store, which contains all your features, also keeps the versioning of it, allows you to do both online and batch. And then once the features are created, you need to have a repository which will allow you to register your models and then keep different versions of it and then be able to consume these models on the same platform. Along with that, we have K-serve, which allows you to do the deployment of the model. That's the whole CI/CD process, which can then be automated on the platform. So HopsWorks is bringing together all of these components in the most optimized way, making your life simple so that you can focus on doing the feature engineering, building the models, and just deploying on a point of the click. There are various applications that can sit on the top of HopsWorks. Entity resolution is one of them, which is more like a horizontal application where you can deduplicate your customers, and then you can have these individual apps all on a single platform, so that there is no inefficiencies or inconsistencies in the process. So today we are going to talk about anti-fraud solution, how using no-code accelerator along with the HopsWorks platform, we have built this solution on the HopsWorks. Okay, so going into the solution overview now. So along with the HopsWorks, we are using a no-code accelerator platform that's called Inferix. So Inferix is a no-code application development platform which allows you to build your applications which are related to machine learning, where you can pull the data, build your features, build the model. The whole life cycle of building a machine learning model application can be performed through a no-code pattern. So it's basically a no-code, low-code platform which allows you to do all of this to point and click. Um, this is just to make your application journey faster. Obviously, HopsWorks is going to be under the hood. It's going to take care of automating all of these processes, but then you still need some kind of accelerator which can allow you to build your apps. In the absence of Inferix, you would be basically using all the Python APIs that comes out of the box from HopsWorks. That's one way to do it. This is another way which can further accelerate your application journey. So, so let's talk about the anti-fraud process flow. So Infinix Accelerator is being used to build this application. This view is kind of showing you how this application is being built. So there are various processes that are implemented, and these are all the components within the application. The first component is really the entity resolution, where we are able to take the customer data, look at all the properties of customer, use a technology called graph technology to do deduplication. So you can perform this on millions of customers in like seconds, and that will give you the deduplication of customer or resolve your identities. Once the entity resolution is performed, then you can basically do the profiling of these entities, which means you are computing summaries at an account level, at transaction level, at a customer level. So these profiling jobs can be run on a periodic basis. So we have Profiler as a component within the platform, which allows you to do that. And then once you do that, then you can perform the machine learning part where you build the features, build the models using the classic algorithms, including the graph technology, to uplift your model accuracy. And then you can start doing the predictions. Once the predictions are done, then you can start scoring this, like you can combine multiple predictions and generate an overall score. So this score, once you apply a threshold to it, you can generate alerts on it. And once the alerts are generated, now you can open cases on it. So these are various components which are built using for this particular application. But depending upon your application that you're building, you can use one or more of these components. You can have something additional as well. So we also have a case investigation dashboard where once an alert is generated, you can run a workflow which will basically allow you to take actions on your predictions. And then all of this can be done on a singular platform, right? And then finally, for your if it's a regulatory application, then you can also generate the regulatory reports on the same platform. So Inferix platform is basically sitting on the top of Hops.
I'm myself is Pallavi from Inferix, so I'll be continuing with this. So Inferix is on top of HopsWorks, where you can actually integrate these things, and you can do all these things like entity profiling, behavioral analysis, risk scoring, alert generation, case investigation, and dashboard reporting. Okay. Uh, the data can be the sources for the system can be a real time or a batch processing. For real time, you can go with the Kafka. The As we said, the Neo4j is in between, where
And sorry, I had some internet issue here. Okay, I had some technical issue. So talking about the real-time fraud detection. So as we saw the overall solution, how it works, this is the deployment. And then as you see here, there is a flow which is being configured for a real-time fraud detection, which is related to the anti-fraud. So you have your source system on your left-hand side. We can pull data out of that using Apache Kafka. If you want to do something more in real time, this data gets into some kind of analytical store. In this particular example, we are using Neo4j, which will allow you to do some graph algorithms and do feature engineering. Once this data gets into the Neo4j, we do the feature engineering. These features are then ingested into the HopsWorks, which allows you to do the feature engineering part and do the machine learning. So once the features are stored in the HopsWorks, we can then do the machine learning models, and then we can build the model, we can train the models, we can deploy them. We can also run the inferences. Once the predictions are made, then we can generate the alerts, and these alerts can then be utilized to block a transaction in real time. So one is to block a transaction in real time. Other thing you can do is you can also generate cases which can then be seen through the case management dashboards by the investigators. So there are two different aspects of it. You can also basically run through the graph. So you can do the link analysis from the case management dashboard, which we are going to show you a demo. So this whole application orchestration can be built using the Inferix no-code platform, along with the HopsWorks system underneath. So now we can get into a quick demo. So let's log into the system and we'll show you how exactly this application can be built out. So this is a login screen. We are going to log in as a demo user. This is the Inferix no-code platform that I was talking about, which will allow you to configure this application. Once you log in, you can see in the dropdown, there are various applications. Today, we are going to focus on anti-fraud. So let's look at the anti-fraud application. Okay. So once you log in, you will see a dashboard. This is a landing page for your application. Now, depending upon your requirement, you can build any kind of dashboards. Out of the box, we are going to have like 15 to 20 different types of visualization, which can be used to build dashboard. This you can do like a drag and drop and configure your dashboards. While the dashboard is loading on the left-hand side, I can go over a few menus. So as you see on the left-hand side, we have the data management component, which is basically covering your data ingestion, data profiling, data quality, data recon, and data archival. And then you have the business rule engine, the alert management, and the case management, which allows you to do the case generation. You have the data science menu, which will allow you to do all the machine learning models and the feature engineering. And then finally, you can create the pipelines, which are nothing but the steps that you need to orchestrate and then schedule them out. So let's go through the dashboard first. So if we scroll down in the dashboard here, you can see there are scorecards, there are bar charts. So we are trying to show you how many cases are open within the system right now, and how many cases are closed, and how many suspicious activity alerts were generated. So, so overall, these are all the charts that you can build using this particular accelerator. So to begin with, I'm going to go through the data preparation first. I'll show you how exactly you can do the feature engineering, how can you build the features. So over here, we have something called data pod. Once you click on the data pod, we can pick a data pod, let's say fact transaction. So let's do a search here, fact_transaction. We can open this. So data pod is basically a table which is pointing to your table in your RDBMS. So I can scroll down and I can see all the columns that are available within this data pod. So these are the columns or the properties that are available in your source system. So what we are going to do is, using these columns, we are going to derive some new features and then store those features into HopsWorks. If you want to take a quick glance of the data, I can click on the sample here and I can see the data as well. So at this point, we are connecting to your source system where the data resides, and look at all the columns that are available. I can quickly scroll to the right and show you maybe a histogram on a currency column. So let's choose the currency column here and do a histogram analysis on that. Okay. And then if I want to see how the data is moving within this particular table, then I can click on the data lineage, and then data lineage is going to show you, how the data is moving within that. So let's go to the data lineage. Okay, so this is the lineage. So as you see on the right-hand side, you have the green icons. These icons are basically, the table from where the data is coming. So we are focused on fact transaction, which is basically the the table in question here, and then these are all the sources from where the data is arriving. So if you click on this green icon here, we see that this data is coming from this data pod, and further upstream, the data is coming from another file called transaction.csv. So using this tool, you can perform the end-to-end lineage. You can see which features are used in a model, how these features are derived, from which column from which tables the columns are coming, and then what is the source of those columns. So we can do n number of hops depending upon how complex is your system, or how many hops your data is taking within your system. Okay, and this becomes very handy because let's say if somebody at upstream system is going to tell you that, okay, we are going to change this column data type, or maybe we are going to drop this column, come up with a new column, what you can do is you can come to the system, you can say, show me all the places this column is being used. So that will help you to do a dependency analysis and see what is the impact of any change in the upstream or downstream. So let's say if you want to build a feature now using these columns, so we can go to formula. Formula is like you're doing some kind of mathematical expression. So features can typically be ratios, they could be calculations, some kind of logic, like a business logic, which is doing some mathematical calculation. So I can pick the, let's say the monthly withdrawal amount here. Let's open one of the formulas. And then we can look at the logic of this formula. So in this particular case, what we are doing is we are just rounding and averaging a particular column. So this is more like a summary feature, right? We get the raw feature, we are kind of taking an average and rounding that number and creating a new feature out of it. So similarly, let's say if you want to do something more complex, which involves a more complex business logic rather than just a mathematical expression, then what we can do is we can write a Java or a Python program and create like a user-defined function and register within the platform. So that would be an alternative if you're dealing with much more complex example. In this particular case, we are just doing a rounding and averaging. So a SQL expression is more than enough. So the formula page will allow you to compose basically any SQL expression, which will derive into a feature. So once you create these formulas, which are nothing but features, then you can go to data set and you can start assembling all of this. So data set is a concept which allows you to join multiple data pods, which is nothing but tables, and then combine these features into a single data set. And then we can choose this data set to put into the feature store. So the initial part is all about the data preparation, which is happening within the Inferix, which is nothing but up to the feature calculation part. Once the features are calculated, then the next step is to write the features into the feature group. So let's go to the data pipeline to see how that is being done. So within the data pipeline, there is a pipeline which allows you to push these features into the HopsWorks data store. So let's open that. The first one, the write feature group. Okay, so this is a very simple simple thing you need to do. What you need to do is once the data set is created, you can use an operator concept. An operator is basically allows you to read the data set, which contains all your features, and then write these features into the feature store. So this is a one-step process, which is nothing but your feature pipeline. Okay. Once the features are stored into the feature store, now we can, start building the model and training the model and see the metrics of the model. So let's go to the data science now and let's see how a model is created. So we will pick one model from here, which is stored in HopsWorks. We'll see the definition of this model. So this is a model which is created for suspicious activity prediction. Here we are using gradient boost tree as an algorithm. Our label is a suspicious indicator, which is available in our data in the feature store. And these are all the features that are sitting in the feature store, right? So we are configuring a model with all of these features. You can also do things like, um, scaling, encoding, imputation. All of this can be done through front end. So this is just to make your life easy in terms of building your models and the whole journey of your application, right? You can certainly write a lot of Python code to do all of this, but if you want to do it in more efficient manner, then you can use this platform to build your applications. It's going to increase your speed by 5 to 10x, depending upon what is the complexity of application. So before I go further, maybe we can take a look at if there are any questions. Nate, any questions do you have from the audience?
One question came in, which is what algorithms are you able to leverage with HopsWorks in the platform?
Okay, so HopsWorks has, obviously you can leverage any algorithm that is available in the open source Python libraries, but from this particular platform that you see, so if I go to the algorithm tab here, there are around like 40 algorithms that can cover 95% of your use cases. So these algorithms are anything that is as basic as linear regression, then classification. You can do classification, and then you can do like community algorithms as well. We also have NLP algorithms. We have some GenAI algorithm, the LLM model, and we can also do, neural nets and so on. So it pretty much is a very comprehensive library of 40 algorithms. But if there is any algorithm which is available in the open source world, and let's say if that's not available, it will be like, like probably like half a day to add a new algorithm into this particular tool. So now I'm talking about the tool, the algorithms, right? But if you are using the Python APIs to access HopsWorks, you can pretty much access any algorithm that's available on the internet or in your open source world. Okay. So we were going, so these are the algorithms. We looked at how a model is created using this platform, and now we are going to train the model. So let's go to the training. So training is a process where you're taking the data from the feature store and running through the algorithm to create a model out of it. And then there are various options when you're configuring the training process, right? So you go to the next screen. Here, what we are going to do is choose the model. So I'm choosing the same model, which I wanted to store in the HopsWorks. I'm choosing my data out of the feature store. I'm choosing the label column, the row identifier, and all the features. So these are all the features that are coming out of the feature store and mapping into my model. And then on the last screen, what I can do is I can do a lot more configuration around this training process. I can turn on the hyperparameters. I can save my features. I can calculate the feature weights. So there are various options here. You can do your split of training and test data set. You can also do some sampling if you like, if you have any kind of imbalance in your data. And then, finally, you can decide to store this model into HopsWorks. There's a drop-down saying model output location, which allows you to store into HopsWorks. So through this point and click process, I'm able to quickly compute my features, push the features into HopsWorks, build my model, train it. All of this can be achieved in like, maybe like 10 to 15 minutes, right? But if you want to write a lot of code using Python APIs, you can do that as well. But this is just going to make it available for the whole community that is using the platform. So once the model is trained, now we can go and look at the results of this model. Okay, so there are various tabs here. The first tab is the summary tab, which shows you which algorithm was used to train this model. What is the type of library like Python? How many features are used? How many rows were used? And what are the various parameters that were used to train this model? So this is basically all the training configuration that we are showing here. Then we can look at the feature importance. So feature importance is nothing but what are the various features that were used to train the model and which features are the most important. So that will get a higher percentage. In this particular case, as you see, there are two features which is taking the maximum importance here, which is the community risk score and the number of degree fraudster, num degree fraudster. So community score is basically an outcome of risk score is an outcome of a community detection algorithm that is used in Neo4j. So our platform is also integrated to Neo4j. In fact, we are official partners of Neo4j. So this allows us to run the algorithms which are present in Neo4j, generate new features, and bring those features as a part of the training process, along with your other features which is coming out of your raw data. So using this platform, you can combine the features that are coming from your traditional RDBMS as well as any cloud warehouse, as well as the Neo4j, right? So we can mix and match between the structured database and the NoSQL databases. So this is the two features at the top are basically the Neo4j graph features. The second feature is the num degree fraudster, which is nothing but how many degree we are away from that fraudster, or this customer is away from the fraudster. So you can compute these features within Neo4j, and we can bring it into HopsWorks, and then you can start training a model. Okay. Then we can look at the performance of the model. So you can look at the accuracy metrics, the F1 score, the precision recall. You can look at the confusion metrics and also see how many predictions were made, both, which is basically 1 and 0s, which are nothing but fraudulent versus non-fraudulent. So that's the last bottom right chart. Okay. If you want to see like how the train and test data was split, so what happens is usually if you have, let's say, 1,000,000 rows, and if you're making a split before training your data, you can click on these tabs, and these tabs will actually show you what exact data was used for training and testing. So this was the data that was used for training purpose. Similarly, we can go to the test tab and we can look at all the test data that was used for testing purpose. So we do like an 80-20 split. If you go to the right side of this particular test data set, we can see what predictions were made for every record year. Let's go to the extreme right. So you can see here, we are making a prediction of 0 and 1. And also we have a probability score, right, for that particular prediction. So let me scroll to a bit left. I can show you the probability score there. Yeah, so this is the probability of class 1 and class 0. Class 1 being fraudulent, class 0 being non-fraudulent, right? Finally, there is something called feature weights. Feature weights is basically what happens is, let's say if I was making predictions on my customer, whether they are fraudulent or not, for each customer, which features have really influenced to make that prediction. So I can pick any customer from here, like in my drop down, and see what is the prediction that was made. So that's one of the feature we have. Okay, let's look at so this is the training process, right? Now the next thing is I want to show you the knowledge graph, which is basically the Neo4j piece. I have some error on the screen, so maybe I can show you later this one. Let's go to the knowledge graph. Okay. So what's a knowledge graph? A knowledge graph is basically a representation of your data in the form of nodes and edges. So I can have a customer node, I can have an account node, I can have transaction nodes, and I can create linkages between those nodes. So we have configured a knowledge graph here called link analysis graph. So let's take a look at that. Now, this is basically using Neo4j under the hood. So as I mentioned before, our platform is integrated to Neo4j, which is a graph technology. And graph technology is very good at, doing link analysis kind of feature engineering, right? So if you have any features which are generated through linkages, you can use graph technology for that. You can also use graph technology for entity resolution, which is nothing but, deduplicating your customers. So that's one of the features within the platform available. So these are all the nodes and edges that has been designed for this particular use case. We have a customer node, account node, address, IP address, transactions, and so on. So I can click on any of these nodes and I can, basically configure what icon to display, what is the color, and what kind of highlighting I need to do. So highlighting is basically you can say that, okay, if this particular account or maybe this particular address falls in a high-risk country, then maybe we are going to turn this into a red color. So along with the algorithmic part, you can also do a lot of visual analytics using the knowledge graphs. And this knowledge graph will be used further down into the case management. So, so this particular utility will allow you to configure the knowledge graph and then push your data into the Neo4j. So if I go to the next screen, then what I can do is I can say I want to write this graph into Neo4j. So this is the Neo4j destination where I'm writing my graph. So using the same platform, you can now not only talk to HopsWorks for your feature engineering and the feature store, but also you can talk to the graph technology, which is the graph database, to build and retrieve your graphs. Okay. So the last part I want to cover is, so let me take a brief pause here, see if there are any more questions.
So Yogesh, one question is, how do you ensure that there's point in time consistency? There's a lot of models that are being trained and then inferences and then applications looking to consume them. Is there a way to make sure that all of the features have point in time consistency?
Yeah, sure. So, so within HopsWorks, everything is being versioned, right? So when you build the features using this platform and push the features into HopsWorks feature store, the feature store comes with, certain features actually. So the features of the feature store, I would say, where one of the feature is like, time travel, right? So time travel happens because of the versioning concept. So every time we are writing features into the feature store, it's generating a new version. And when we are training these models, or anybody's training these models, they can pick a particular version of the feature data set that they want to train upon. Okay. So we just need to make sure that, so by default, you are going to train on the latest version of the features. But if you want to do a point in time execution, then you need to choose either by timestamp or either by a version number, that what feature data set you want to use. As long as we are making sure all the models are being trained using the latest feature data set or a particular version, they all will get the right data at the training time.
Thank you, Yogesh. There's no other questions at this time.
Okay, so now let's take a look at, so I think what we were doing is we went through the feature engineering process. We see how a model is being trained and stored in HopsWorks. So now the next step really is like, once the predictions are made, how can we consume these predictions, right? Like, what is the action we can take? So within this Inferix platform, what you can do is you can configure the business rules and alerts and the cases. So let's look at one of the business rules. Let's go to the business rules. We can open the first business rule. Okay, so this particular rule is outgoing round amount wire transfers. So what we are trying to do is, one option is, you can build your rules, or you can generate your scores on the raw data. But what we are doing here is we are taking some portion of the raw data along with the predictions that were made using the machine learning models, and then we are generating an overall score. So the business rule engine will allow you to point to your data, the predictions that you made, and then also you can do some filtering if you like. So I can do some filters here in the bottom section. Then I can go to the next screen. And now I can define my criteria. So each of this criteria can be your prediction. And now you can say, I have like 3 models, but making 3 different predictions for the same customer. And I want to give different weightages to each of the model, because maybe one of the model is, more superior than the other. Maybe it has a better accuracy, but you don't want to discount the other 2 models. You want to do some kind of weighted average scoring across all 3 models. So this business rule engine will allow you to point to those predictions and provide some kind of weights and define some scores. And then finally, when you run the business rules, we are going to generate an overall score for that particular customer and every customer, in fact, that is that we are trying to predict upon. So that's the the scoring part. Once the scores are generated, we can apply a threshold to it, generate an alert, and also generate cases. So let's look at an alert rule. So let's go to the alert management and let's look at one of the rules. So what we are doing here is we are kind of combining all those rules, the business rules that we created, right? We can take all those scores and we can say we want to normalize the score between 0 and 100. And if the score is beyond 70, then we want to generate an alert. So this is how you are going to combine various alerts, various scores into a single alert. Because what can happen is you may have multiple rules firing on the same account, and each rule is going to compute its own score. And then now you want to combine all the scores and generate an overall one single alert. Okay. So let's understand a situation where, let's say, in the banking world, you have customers and then each customer can have multiple accounts, right? So I can generate alerts for every account. Now, if I have two accounts and if I have two different alerts, I don't want to investigate the same person twice. So I can further do aggregation of my alerts and generate one single case out of it. So that's the concept of the case rule. So let's look at one of the case rules. I'm going to open the case rule here. So in this particular case rule, what I'm doing is I'm taking that alert rule that was generating the alerts and then saying that, okay, further I want to normalize if there are multiple alerts using a normalization technique, apply some kind of threshold, and then based on the threshold, I want to generate my cases. Okay, so this is how you will configure your case management. Once that is done, then we can run this engine and it's going to generate your cases and alerts in real time. So let's look at one of the cases that are already generated in the system. So I can go to the results. I can see how many cases are created. So there should be around 2 cases at this point. Let's open the first case. And then, okay. So we are on a case summary tab. This is showing you a summary of the overall case, like the case is open for which customer, the customer ID, what is the severity of the case, what is the priority on this case, and so on. The next step shows you the details about that customer. So now you know it's on customer ABC. I want to see all the details. So here you can see all the details. This is a very configurable platform. So what you can do is you can configure whatever fields you would like to display on this particular screen. So I'm looking at the customer details. Now I want to see what alerts contributed to this case. So I can look at the alert. I can drill down into this alert if I like. So I can click and drill down into it. So as I mentioned before, the alerts are configured to generate at an account level. So now I'm looking at an account information. So if you see the entity type, that's account, and the entity ID, that's a number. So this is basically the account number. And below in the tab, you can see all the account related details. And now I want to see like which rules contributed to generate this alert. So I can click on the rule tab. It's going to show me all the rules that got triggered. And each of these rules can be consuming a prediction that you made using the machine learning model. Because when you build an application, you don't just build a machine learning model and end there. You actually take those predictions, run into some kind of business process to come up with the alerts, and then assign those alerts so that the investigators can take some action on it. Or maybe you send it to an application which can stop a transaction in real time for you, right? So this accelerator will allow you to build your application end to end and complete your journey of the application. If I want to see like what other accounts this account is transacting with, then I want to do some kind of link analysis. So I can click on the link analysis, and that will show me which other account this account is transacting with. Now, this is something about linkages. So what we do is we connect to the Neo4j graph, we pull the data, and we display you back. So here, if you see an account is transacting with other accounts, I can click on any account, and I can say, show me details of that account. So let's click on that, show details. Okay, let's right click and then show details. So if I double click, it's going to open the node. If I do right click, I can say show details. Okay. So that's the show details. And you can start exploring the graph as you want, right? As you do your investigation. I can put some notes on this alert. I can do some documentation. I can also generate some kind of notification if I want to alert somebody. Okay. So I'll close it and go back to I'll go back into the case management now. Okay. So the case was generated on a customer. So what if I want to see what else is connected to the customer? I can do a link analysis at a customer level too. So earlier we saw at an account level. Now I'm doing at a customer level. So customer is the red icon here, and the customer is connected to an address. It is connected to an account. If I want to see which other account this customer is transacting with, I can just double click the account and I can open that account node. I can close this right-hand side pan here. I can see all the accounts. So this screen will allow you to do your investigation and also leverage the power of graph. So what we are trying to do is we're trying to bring in all the best technology in one place. We're trying to bring in the HopsWorks engine, which is doing all your machine learning, feature engineering, predictions. And then we are also leveraging graph engine on the other side to perform network analysis and build your features like graph features, and then also use it as a part of your investigation process. The last piece is then I can do some notes, and similarly I have flow of funds. which will allow you to see how your money is moving between accounts. So here you can see that there are 4 different accounts, which is transferring money into one single account. And this money is for the transferring money into 4 other accounts and 2 accounts, so on. So, so this is basically also coming from the Neo4j graph database. Depending upon how your accounts are transacting, I can visualize this. The size of each of these, visualization tells you how much money is actually moving between accounts. Okay, the thicker the size, that means more money is moving as compared to the thinner edges. Now, I can put some notes if I want to put some documentation around this investigation. I can attach documents, and then I can also do a workflow around it. So, so this is the last piece of my demo I wanted to show you. So what's basically a workflow? So imagine I generate an alert and I've created a case, right? Now, somehow I need to notify to somebody or assign this case to somebody. I mean, not every investigator is going to know without informing, or not everybody can get into the system, right? So we have to do some kind of assignment of the case. So in the first step here, what we do is we initialize the case, then we get the case details, and then depending upon in which region the case is generated, we are going to find out to which group it needs to be assigned to. Once we determine what group to assign to, then it will automatically assign to reviewer 1, reviewer 2, and so on. And then we can send them periodic reminders in case they are not really opening the case, right? Let's say if it's more than 24 hours and if they have not opened the case or checked the case, it could be not a good situation. And that is why we keep these reminders. So depending upon what's your business requirement, we can configure this workflow. So this workflow also comes as a part of the Inferix no-code platform, which allows you to build your workflows just to point and click. Okay. So I can scroll to the right and I can show you the complete workflow here, what else is available. And then finally, you can, close this case if you know exactly if there is any fraudulent activity or not. Okay, so this is just an example workflow that we created for one of our customer, but you can see it's pretty complex. And if you want, you can also build further more complex workflows. So within the workflow engine, you can call a service, which could be calling some API or maybe some Java program or a Python program, which can take some action. And also there could be human steps involved where you may want to ask the human or an investigator whether what to do with the case, right? Does the investigator wants to assign this case to the next level, or maybe he wants to close the case, and so on. So there are many actions that you can perform, and all these actions can be configured within the workflow engine. So on the menu on the left, you see there's a workflow manager, which allows you to configure this workflow and then associate the workflow with the case management. Okay. So, so this is about building the configuration, the whole application. Now, the next step, the last step is really to orchestrate everything end to end, right? So I'm going to go back to data pipeline because I want to take these business rules, I want to take the alerts and cases and assign these cases. So I can open the pipeline, which is related to the rule engine. So let's open this. Let's go to the next screen. Okay, so here you can see the purple icons are basically doing some transformation. It's computing some summaries. This is basically the pipeline post prediction. Okay, so the first pipeline we saw was related to the feature engineering. The second pipeline was related to training and predictions. And once the predictions are made, as I mentioned before, we want to run the rule engine to generate some scores, and then using these scores we can generate alerts and cases. So the blue icons on the right, you can see those are all related to the rules. Once the rules are triggered, then we can fire another stage here. The stage is basically the bell icon, which is kind of showing you how to generate the alerts. And then once the alerts are generated, then you can create a case. So you see a brief case, which is more like a case. So I can point the arrow there to show you where is the case management. Okay. So once you run this pipeline, you can schedule this pipeline to run on a periodic basis, and then your alerts and cases can generate. You can do like every 2 minutes, every 5 minutes, depending upon whatever may be your business requirement. Okay. So this is about creating a pipeline. Once the pipeline is created, then I want to schedule the pipeline. So we have a batch scheduler, which allows you to take this pipeline and schedule it to run on any frequency you like. What if you want to monitor all the jobs? So I can go to job monitoring, and then that can allow you to monitor all the jobs. So there are various types of jobs that are running as a part of this platform. You have a feature pipeline, you have training pipelines, then you have inferences, you have alert generation, case management, workflows. All of this can be kind of monitored from here. So let's say if I want to look at all the training pipelines that were run through this system, So I can just search for train here. Okay, I can click on this and I can quickly switch into to see how many pipelines were triggered, how many succeeded, how many failed, and so on. Okay. So, so this is pretty much the overall. And then what you can do is you can take all these alerts and cases and you can build a dashboard, right? So if I go back to my dashboard here, let's go back to the home page, which had the dashboard. And this is the dashboard which was showing you right in the beginning when I opened the application. I showed you how many alerts were generated, how many cases were generated, and so on, and the various charts, right? So as you can see, I've covered the complete journey of taking the data from my source system, building the features, pushing those features into HopsWorks, creating my predictions, alerts, cases, workflows, and then also interact with the Neo4j graph during my investigation process. And then you can build this dashboard for management purposes or for regulatory purposes. You can also generate the reports using the system. Okay. I'll take a brief pause to check in case there are any questions at this point. Nate, any more questions if you have?
Yeah, Yogesh, this one's kind of a combined question. So what additional data sources can you bring in to HopsWorks? And, suppose we have a large amount of data, as you can imagine, with fraud and the such. How large of a data set or how varied of a data set can you bring in?
Okay, sure. So let's go to the admin section here that will show you what sources you can pull the data from. So I'll go to the admin section. I'll go to my data sources and then open one of them in the edit mode. Let's open and edit. And then when I'm creating a data source, which is basically connecting to my source system, I have a drop down that shows me what are the different categories. So if you see here, I can bring data through APIs. I can bring from document databases like Mongo. I can bring data from feature store, which is HopsWorks, a file system, graph database, any RDBMS, whether it is MySQL, Postgres, Oracle, etc. And even I can pull data from Kafka streams or even Spark in memory. So we have like built these connectors which can literally bring data from any popular databases or systems that are out there. So if I click on RDBMS for an example, to show you what RDBMS we can bring the data from. So let's click on RDBMS. Okay, and then let's go to the type. Okay, so here you can see the holistic list, right? DB2, generic, which can be any JDBC, Hive, Impala, Kudu, MS SQL, Oracle, Postgres, Snowflake, etc. Right? So right within RDBMS, I have at least like 10 to 12 different types. And then if I go through each category, it's going to combine and make it like at least 15 to 20 different systems. Now, this is about what type of sources can you connect, right? Now the question comes whether you can bring data in real time or batch. So we can bring data in real time or batch from any of the system. So if I go to my data ingestion, so let's go back to data ingestion. Okay. And then I can create one rule here. I can go in and add mode, say. Okay, so there is a drop down. Just scroll down, and then there's a drop down which shows me, yeah. So this is kind of telling me that what could be my source and target. I can do file to file, file to graph, graph to table, table to graph, and so on. And then there is a type which allows you to choose whether it should be real time or batch. So let's say table to table. Let's click something. And then look at the refresh type. This is batch or real time. So if you do a batch, we use Apache Spark to read the data from the source system, bring it into the memory and push it into HopsWorks. That's one option. If you want to do real time, we are going to open a Kafka job, which will read from your source system and push the data into HopsWorks. But if you want to do any transformation or feature calculation, that can be performed within the memory, and then we can push into HopsWorks. So both the options are available, batch and real time, and you have more than 20 plus sources to pull the data from. With regards to the volume of the data, it all depends upon if you have a larger volume, then we have to configure our cluster, the Spark cluster accordingly, because we use Apache Spark to move data around. Okay. You can also do using Pandas data frame, but the thing is the data frame in Pandas can only handle, let's say, few gigabytes of data. But if you want to do multiple gigabytes, like hundreds of GBs or terabytes, then I would recommend we should use Apache Spark or Kafka, depending upon whether you're doing batch or real time. Okay. Any other questions, Nate?
None at this time, Yogesh.
Okay. So I think I'm done with the demo. Let's flip back to the presentation now so that we can summarize about our demo and this particular application. So I have one last slide to go over. Can we share the screen, please?
Hey, Yogesh, while we're waiting, two more questions. How do you join and transform the data from different data sources and load it into HopsWorks? And can we transform after loading into HopsWorks? And then the second question, how does one operationalize this for real production applications such as deployment and release across different release environments? And if you'd like me to repeat anything too, Yogesh, just let me know.
Okay, sure. No, I think I got both the questions. So while I answer this question, Nate, maybe you can share your screen and show the last slide, summary slide. So what you can do is, like, I think the first question was how can you connect across various systems, right? So maybe some of your data is coming from, let's say, a traditional RDBMS like Oracle or MySQL, and another could be coming from Snowflake. So we can actually take data from both the systems and do a join in memory within Apache Spark. So when you run the Spark job, it's going to read data from both the systems and perform that join in memory and then write into HopsWorks, into the feature store. Okay, so we can do homogeneous joins, we can do heterogeneous joins as well. This doesn't matter what type of system it is. Okay. With regards to, I think the second question was about deploying this in production, correct? So when you're using the system, along with the accelerator, when you're building the application, it's a production ready application. You're not writing or doing something in a sandbox. If you like, you can build your models and do your feature engineering right in production, but I would not recommend that. So generally people have a prod and non-prod environment. A non-prod environment is more like a QA or UAT environment where you will bring your production data and do your feature engineering, you will do the training process and so on. Once the model is trained, there is an export utility which allows you to move this model from your lower environment to a higher environment. Okay. And then we can also do a CI/CD automation around this. So you can move this models and feature logic, etc., all of this into production using an automated CI/CD process. So we have created APIs which allows you to export the metadata and then import the metadata back into your production system. Can be achieved that way. If you were doing some custom scripting using Python world, then you will have to obviously do it at your end. But if you're using the tool or the accelerator, then you can use the export import utility and integrate in your CI/CD process. Okay, so scale is not an issue. Heterogeneous joins is not an issue, and also automation of your configuration from one environment to another environment can be achieved using the accelerator. Okay, so just to summarize on this particular use case and the overview of how the Inferix accelerator and HopsWorks works together, all of this works together. Obviously, why we want to use machine learning. We want to use machine learning so we can lower the crime. We have lower fines, and it's a reputation of the bank and customer satisfaction, right? So HopsWorks will allow you to manage all of this, improve your bottom line, and make better predictions. It'll make faster predictions. It'll make better predictions because you are working on a centralized system here, right? It's an enterprise-ready system with all the features when it comes to security, governance, and also your performance. And this is a continuous learning process, right? You are not going to build your model once in your lifetime. You want to build a model, you want to run as many as experiments possible, you want to keep retraining in production to keep improving your models. So we have an ability where you can call an API for making these predictions. Every prediction that you're making, we are keeping a track of it. And then you can provide a feedback through your application, whether this prediction was good or bad or false or true. And then based on that, we can retrain your model, which will keep increasing your accuracy or make your accuracy better. Okay. In terms of the volumes, as you know, we can handle in terabytes of data because we use the best of the technology like Spark and Kafka. which are all horizontal scale technology. We use K-sub for deploying your models. That is, again, a very robust technology for getting the best performance for your machine learning models. We guarantee you the 6 nines of availability in that case. Also, it's about the faster time to value, right? I mean, you can certainly start a Jupyter notebook and start building everything. Every developer or a data scientist can work in silo and hand over all of that code to engineering, and then they have to go through few months of redevelopment and testing. It's not just testing or integration, right? They have to literally take that code, optimize it, and redeploy it. So instead of that, if you're using this accelerator tool, you can actually build everything in a very consistent way and more effective way. And then these configurations can then be exported to your CI/CD process to make its way into production. So that saves you a lot of time. So overall, I would say HopsWorks is a platform which allows you to centrally manage your features to be more consistent, efficient, and have a better accuracy and at scale, right? Including the performance part of it. So, so yeah, I think I would wrap up at this point. I would hand over back to Nate. In case you have more questions, we are happy to take it now, or you can just drop us an email.
Thank you, Yogesh. Terrific presentation. I'm sure everybody enjoyed it. There are a lot of very positive comments coming back. Thank you, everybody, for joining the anti-fraud webinar today. If you have any questions or you want to get in touch with us, please feel free to reach out to me on LinkedIn, Nathan Greenhut, or you can email me at nathan.greenhut@hopsworks.ai. Additionally, if you need more information, we have our website, our GitHub, and our Slack, which I put into the chat. And hope everybody enjoys the rest of your week. Thank you, everybody, for joining.